All right. Hello, everybody. Good morning, good evening, good afternoon. My name is Alexander. I'm part of the Neo4j Developer Relations team, and I'd like to welcome you all to this workshop today. The trainer is Irina Login today, and she has a little bit of a technical issue today. So I'm hoping she can join us soon, and then we can kick off the workshop. But we'll give her a couple of minutes. There were a bit of technical issues today, this morning with the training, and then on her side. So I'm hoping we can sort this out before we kick it off. Maybe we'll cover a few other things that I'd like to mention, which we usually do at the end. So maybe we'll do it the other way around. So we obviously do regular live streams across various channels at Neo4j. So if you are just joining for the workshops, maybe you're not aware of these, you can follow us on LinkedIn, you can follow us on YouTube, and where we do regular, interesting, I would say, talks from the community, from community members, from the Neo4j staff team, from Neo4j engineering, to talk to you about interesting products, interesting new features that have been added to the product, interesting community showcases. Experts from the field, especially from the world of graphs and AI, come and share what they're doing, what they're building, and how they are successful with graph databases. So if this is something you're interested in, follow us on YouTube or LinkedIn. Just the other day, yesterday, I was joined by Sebastian Müller from Wireworks, and we did a great session on AI agents, using AI agents to build graph visualizations across various use cases, with supply chain management, for example. That was one of the example data sets we used, and we just used an AI agent and an LLM to get a nice visualization done as a proof of concept, and without much coding ourselves. So that was really fun and interesting. So if that is something you like and you can imagine doing every now and then join us there. The next stream we're going to do is on the 9th of December, so in a couple of weeks' time, where Jesus and I will do our regular Going Meta series, if that is something you're interested in. So here we talk about knowledge graphs, GraphRAG, obviously, so very topical to today's training, but also we talk about semantics, ontologies, taxonomies, and all that stuff. So it's a very interesting field, I would say, and a very good match between what graph database can and where they excel at, and how ontologies and taxonomies work together with these and how a graph can benefit from having an ontology, and how your data can benefit from having that. So that's happening in a couple of weeks' time. Also, I'd like to announce Nodes AI 2026. So on the 15th of April, so a couple of months away, but still, is our Nodes AI event. If you have been following the Neo4j team, then you probably have seen something about Nodes that happened earlier this month. So beginning of November, we had our Nodes 2025 edition. This is covering all topics, and all the videos are now available. So if you are interested in watching some of these sessions that you might have missed, you can join also on our YouTube channel a playlist and watch all of the videos there. If you are more interested in AI, then we have a specific AI event coming up on the 15th of April. The call for papers is open, so if you are further ahead and want to showcase what you're building with AI, how you use graphs for an AI application, on how you are succeeding here in this space, then let us know. Submit the call for papers. That's open until mid-December, so you have some time for that. And if you're just generally interested about the topic and want to learn more and want to see what's going on, I welcome you to register for the event and be part of it. It's going to be very, very interesting and a very fun day. Cool. Let me check with Irina. All right, she says, okay, she's joining. All right, so Irina should be here in a moment, and then we should be able to get going. All right, here she is. All right, hello. Good morning to you. How are you?
Hello, hello. Good morning. Apologies for the delay. My system tests seem to take the best out of me.
No
I'm
worries.
good, thank you. How
I
are you?
I'm good. I'm good. I covered a couple of basics here, and just wanted to say before we kick things off that we have a Q&A panel here as part of the big marker screen. So you can choose to write if you have any questions, any issues, then let us know there. You can use the chat for anything else. Just type away, like Tony, who says good morning.
Yeah.
So it's open, and we're recording this video. So this workshop today is recorded. So if you are not able to join for the full time, or maybe you come late or you have to drop off early, or you want to watch something again because something was not quite, maybe something was a bit quick or something, then you can always watch it later as a video recording. Cool. I think we wanted to kick things off with a little poll, right, Irina?
Yeah, let's do it.
Let's do it. So I have Paul here, and Paul says, which of the following best describes your current level of interest in using knowledge graphs and the GraphRAG for AI readiness? Are you exploring actively, piloting even solutions? Are you just in inverted commas, right, in early research stage, just seeing what the options are? Are you considering this for future strategic plans, or are you really just curious? You don't have any plans right now, but maybe later on. It would be nice to see what your what your status is, and how you are currently looking at AI and GraphRAG with your current projects or your current development teams. All right, let this run for a little bit. I'll stop screen sharing so you can take over, Irina.
Of course.
And then we have that here out of the way. And I think we can kick things off again. Sorry for a little bit delayed start today, but I'm sure we can catch up on the content, and as always, we try to make it as interactive as possible. So if you have any questions, anything unclear, any comments, any feedback generally throughout the day, then please let us know in chat or in the Q&A panel, and we'll try to find a couple of spaces during the 2 hours we have together to answer the questions. I'm around in chat for the full time, so obviously I'm not be on camera all the time, but I'll be here. But yeah, with that, Irina is part of our technical curriculum team, the Graph Academy team, that are writing amazing courses on Graph Academy, building these out. And she's an expert in the field, and I'm very happy to have you around today. So thank you, Irina, for joining us.
Thank you, Alex. I would say, considering the high number of live streams you have organized, you can also be considered an expert, but no pressure. Yeah. Thank you for having me, and thank you for seeing everyone on the chat as well. Please feel free to share what you would like to learn in general in Graph Academy, and also with regards to GraphRAG. So I can see some of you are already exploring GraphRAG on Graph Academy, so that's great. It means you are already ready to go. So with this said, I am going to share my screen. Please let me know if you can see my screen.
Yep, screen is here.
Awesome, thank you. So today we're having a fundamentals workshop. It means this is, if you are already familiarized with the topic, this is just a quick recap for you and giving you more additional information. If you have just started, this is also a good place to set up a good knowledge base. So if you'd like to connect, this is my LinkedIn QR code, and I'll be happy to hear more about your learning journey. In Graph Academy, we are working on a lot of courses. So if you'll see some tiles with the courses, such as coming up soon, it means we're going to release soon some new topics. and you can pre-register your interest if you want to get started with Neo4j and just set up the basics. You also have the fundamentals, which is what we recommend for you to be successful on this workshop. So if you haven't done this already, don't worry. You will be able to catch up later on, but this workshop is created starting from the assumption that you haven't done all these courses so far. So don't worry if you haven't done this already. So what we'll need for today is for you to create a free account in Graph Academy. If you haven't done that already, it only takes a few seconds. Thank you very much for sharing the link, Alex. And you would also need to access our workshop for today, which is going to be available as long as as long as we have it online. So you can always access it. You don't have to. There's no timer for it. So if you want to take your time to go through the topics, you can also do that. What you will need today, and I will copy and paste this to Alex as well, so we can put it in the chat. This is the most important part of this workshop. This is the OpenAI API key. So you can use your key as well if you go on the OpenAI website on platform.openai.com. But just for this workshop, this is the key that you will need. If you want to follow along, if you want just to watch, that's also fine. So you will need this key to be able to run the algorithms and the queries that we will go for today. So in Graph Academy, you have a lot of courses. We'll go through this, what else is coming up at the end of the session. So let's crack on. Okay, so once you are on Graph Academy, you should be able to see something like this. So when you go to all courses, you will see all the offerings. But for today, you will see something like this. So if you haven't enrolled yet, you'll be able to do that. If you'd like to unenroll and go through it again, this is where you can do it as well. So when you go through your for your account, you'll be able to enroll and also favorite the course. So I'll go for the first part. All right, so how many of you have already implemented some sort of Gen AI engine? Let's see on the chat. Nobody? Okay, that's fine.
Well, we can quickly have a look at the poll, which said 35% are actively exploring or piloting solutions, and 19% are in early research stage. So that's about half of the participants, I would say, and the other half is considering and just curious. So I think I would say half and half. Half of our attendees today are already doing something, and the other half is more exploring and curious about what it can be and if that is something for them.
Yeah, that's great. Thank you for sharing. So if you have already started, you will be already familiarized with what is a Gen AI model, or how can you create a pipeline. But if you haven't, this is the right time for you to either recap or understand the basics. So the Gen AI refers to the artificial intelligence systems that we have. And these are designed to create new content. So the new content will be either based on what the model already knows or what you would like the model to know. So what you're training the model further on. So we are training the model. It means we are teaching the model in doing something. And then we apply the model towards either an existing data set or a new data set, and we will obtain an output. So we should differentiate between these topics. The intelligence part of an AI model is not the same as the intelligence human part as well, right? So it won't be self-led unless you probably decide to create some agents that would be self-sufficient. So they don't understand or comprehend the content that they generate. Perhaps some of you have already experienced some scenarios where you would ask a GenAI engine a question and they would give you something totally different. And this is because they don't understand what they generated. They just look at what they have been trained on, and based on that, they will give you something. Sometimes it is a great answer depending on how well the model has been trained. Other times, you will have some funny answers, and you will need to maybe readjust the prompt and or retrain the model on more data or work on tuning and performance. So they rely on statistical patterns and correlations learned from their already existing training data, right? So previous data, previous knowledge is important. And the context that we create is going to decide on the accuracy or and the results for later on. So the large language models, these are used for text generating, and they will focus specifically in our lessons. We will have our own, let's say, special packages that we will use, and you will be introduced to those as well. So for example, we have here a response generated by an LLM. And let's say if we have an ABC sequence, the LLM has been trained on that, and we want it to continue this sequence of letters, it will respond something like this. So based on what has been already trained, you will obtain a similar answer on that. So thank you very much for adding your answers to the chat as well, exploring basic RAG. And some of you are already working towards GraphRAG, which is great. It means you are exploring more ways of generating data. So a prompt is a task that you ask your GenAI to perform. In this example, we ask what is an LLM, right? So we give the response using simple language, avoiding jargon. So this is the criteria that we would like our GenAI engine to respect. So we have the answer, and that answer has been provided based on the data that it has been trained on. And this is very important, and that's why we set up the emphasis on that, because the data that we use to train a model on will be used later on to provide the responses. So if you if you would want something more descriptive, it means that you will need to train the model on something more descriptive as well and enrich its vocabulary. So treat it as a tool that it's learning new words as quickly as you feed them these words, right? So if you teach them more words and more knowledge, then it's going to express more knowledge later on. Okay. Any questions so far? If not, we can carry on.
There was only one question from Daniel. Daniel asks if Hugging Face models can also be used instead of OpenAI. I think because when you shared the OpenAI key, I don't know if we go into different models or if, I mean, for the workshop today, we just use this model, I know, but generally maybe how is that in terms of possibilities?
Well, you're hinting towards the answer. So yes, in general, if there's a model publicly available, then you should be able to use it, right? So I would recommend start experimenting with different models and evaluate which one works best for you in your context, right? Because depending on the type of knowledge you want your GenAI to know, you might have better models on the market. So yeah, it's a good idea to do some research and evaluate what you currently use, and maybe take the decision later on which one to get started with.
Absolutely. Thank you.
Okay, thank you. So we need to have a caution disclaimer here because sometimes we might have some answers that are not technically accurate, but we would need to focus on the context and the patterns and relationships that we have set up in our graph. And because of that, we are using today a graph database and we will try to train it and later on obtain some results. Okay, so the sources for training our data. You can use any sort of sources in general. I'm not talking about the workshop of today, but in general, whatever publicly available resource you have as a text, you can use it as a training data. So the training data can be obtained from various websites that provide that free of use as well. And you can experiment as much as possible. The recommendation is for your model to be trained on as much data as you can, because later on you would like it to be as accurate as possible as well. So we have here a funny prompt. So tell me about the latest Neo4j features. Now the LLM is going to provide the data that it has obtained, the information it has obtained based on the training data. So probably if you have enabled web search, it's going to go and search for the latest news, the latest websites, the Neo4j documentation, and so on and so forth. So based on that information, it's going to give you the answers. It will not create information without without the resources to obtain that. Okay. So in terms of accuracy, I have described a symptom that in GenAI we call it hallucination. Now, how many of you have heard of this term of hallucination of GenAI? See? And if you have
Let's see. I
found,
would I wouldn't be surprised if everybody heard of it and everybody
yeah,
had probably experience, even if you have no interest in or have just researching or just exploring or playing around with things. Everybody probably put some query prompt into ChatGPT or some other AI and got some weird weird answer. Yeah, lots of yeses. Yeah.
yeah,
Hear it
yeah,
all the time, said David. Yeah, you get that.
yeah. And then if you have tried to correct the hallucination, what happened? I'll go
Yeah.
first.
Yeah,
The
you
Oh, you can
go
go
first.
first.
Yeah. No, I mean you try to correct and you help out and say, yeah, this is not what I meant. I meant this other thing, and then you try to explain even more. And
Yeah,
sometimes it helps, sometimes it makes it even worse. So it's
yeah,
it's yeah.
yeah, exactly. So most of the time, the hallucination becomes even worse because the data that you're giving it perhaps is not the most accurate, or you don't provide the accurate data set to be trained on. So, for example, if I want to obtain an accurate answer from a GenAI engine, I also give a source of truth, because otherwise it will just go back to the same sources of truth and just provide the same hallucinated answer, although it will apologize, right? So this is an experiment for you to try as well. Describe the moon, ask GenAI to describe the moon, and you will see some funny answers. Okay. Also, LLMs have the concept of temperatures. And this is measuring the amount of randomness that the underlying model should use when generating text. So the temperature sometimes can be set up by you if you're designing your own GenAI model. Other times, for the public market ones, the temperature is already preset. Okay. So consider the correct temperature here, and we see more news like this in the latest news. In June 2023, a United States judge sanctioned two United States lawyers for submitting an LLM-generated legal brief. So that means that those lawyers have used a LLM-generated paragraph of citing laws that don't actually exist, right? Someone is asking, can humans also hallucinate? Well, it depends what sources of truth you are referring to, and you can relate inaccurate information if your sources of truth aren't accurate as well. Okay. Another important part that we will need to set up in our GenAI engine is the transparency. So, how did you determine that answer? And then the GenAI should reply back with, I have used this site and this site and this site. And lately it has become more transparent the more we have worked on improving these engines. And also, we have requested an improvement as well. So you will see more laws coming on the market about the transparency, about how GenAI should be used, how should we code GenAI, and so on and so forth. And you can do your own research on this. It's a very interesting topic. Okay. So let's start with the Retrieval-Augmented Generation. Okay. Now, when you enroll on this course, you will also have a sandbox instance. So this is going to be a Neo4j sandbox instance that you will be able to use to perform the tasks in this workshop. If you'd like just to watch and follow along after that, and maybe later on you'll also watch the recording, pause it, experiment some more, you can also do that. So it's totally up to you. I wouldn't force anyone to write the code as we go along. You can do it also after, but if you want to do it now, you can also start. So, has anyone ever heard of RAG? I've seen some questions and some answers that they are using RAG. So RAG is Retrieval Augmented Generation. So that means we will retrieve an answer and we will add to it based on the knowledge graph that we have built as well. So RAG is an approach that will enhance the responsive of the large language model that you have, right? Because we want this information to be as rich as possible and also as accurate as possible. So we use the training data, we use real data, and we also add more knowledge to our data sets, and that knowledge is going to be in the shape of a graph, because that would set up patterns and relationships between the items of information, if you'd like to call them so, that would help you get more insights of your data. So what is the RAG process? Let me know if you can see this diagram, because we always seem to not get it as big as possible. So is this clear enough?
Yeah, this looks good. This
Thank
is
you.
very big. Yeah.
Yeah, that's okay. Thank you. Okay, so we have a few steps that RAG is performing. So it will start with understanding the user query here. Great, thank you for your feedback on the chat. We have a question. So the question that we ask is going to be the answer that we want to obtain based on the data that we've trained. So let's say we have a prompt here. How is the weather today? Okay. The application is going to go to the retriever first, is going to give the question, so passing on the question to the retriever. The retriever is going to then go to the data store and see, do I have any information about the weather today? Get the answer back, give the context obtained to the application, and then the application is going to provide an enhanced prompt to the LLM and give the response. So this is a more augmented or enriched information that we can obtain based on a graph data store. So the RAG process is going to actually give you the answers based on real-time data and also public data. So you can use multiple types of data that will be fed into your LLM and into, in our example, the news chatbot. So this process is going to improve the accuracy of the LLM. Is not meant to to replace the LLM, but is going to improve the LLM that we have, because we want to work with the data that we have, but we want to make it as rich and as accurate as possible. Okay, so the retriever is a key component because this is going to go into the data store and see what information we have already. So imagine you go to the post office and you ask the desk assistant what kind of newspapers they have of today, and they will go and check in the stock and come back to you and say, here you are, this is what we have of today. This is exactly what a retriever will do. Okay. So this is responsible for searching and retrieving relevant information from external data sources. Okay, so we can give an unstructured input. So for example, the prompt that we give is going to be enough for the retriever to go and check in the data store. And we have three main categories of what Neo4j supports in terms of retrievers. So we have a full text search, so we can search in the text using the Neo4j libraries and databases. We can do a vector search, and we can do text to cipher. So these are the main three categories of retrievers that we support at the moment. So we will go through them in this lesson as well. So in terms of data sources, we have documents, we have APIs, and we have knowledge graphs. We won't exclude a document from an API because the more knowledge we have about a topic, the more accurate and the more enriched we can obtain an answer depending on that. So in terms of data sources, we can integrate all of these to feed into the final answer. So we can do that with the retrievers that we have, and you will see also in our examples as well. Okay. So moving forward, going one level deeper into the accuracy levels, we also introduced the vector RAG. So the vector RAG is going to give you another level of retrieval and obtaining the information. So that means that we will do a semantic search. We will store the information based on vectors. We will search the information based on vectors as well. And we will see how the results look like in our database. So the semantic search is going to be a word search, right? So it's going to give some context, it's going to try and match the exact words, it's going to find a proximity meaning of those words as well, and you will have to also give some more information in case that is needed. Okay, so a vector, this is the mathematical representation, but I'm not sure how many of you have actually done math. I've done math, and for me, it would be easy to just skip this part, but I'm sure for most of you, this is not a familiar topic. So let's dive into it. So these vectors are representations of numbers because computers, they, at the basics, they work with numbers. So we have to find a way to give a computer a numerical representation of the words that we have. So we have an extremely large text. The machine at the basics won't understand the words, right? We will need to convert these words into numbers. So that's why we have vectors that we are using in the GraphRAG process. So here we are representing, let's say, a list of numbers. So we have here 111 and 123. So these numbers are going to be the representations of some words, and if they are close enough, it means there's a similarity between them. If they are extremely far away, they might not be related. There might be no similarity between these words. Okay, so if we have here 3 numbers, this is the dimension of the vector. So the more numbers we have, the more accuracy and iterations we can have over these vectors. So the more the merrier, right? So if we have a more concentration of dimensions here, we will be able to find more similar words as well. And based on vectors, we also have embeddings. So when we are referring to the vectors, the term embedding is used. So the embedding is the coding of the words. So the encoding of the words, right? So for example, the word apple might be represented by an embedding following a fruit, a technology, a color, a taste, a shape, and so on, right? I don't know if these are all the meanings of the word apple. Please let me know if you find another one. Okay. So we don't have to reinvent the wheel. There are so many embedding models already on the market that we can get started with to evaluate and to train the model based on our data. And we will use an embedding model today as well. That's why I gave you an open API key. Okay, so we can create embeddings based on individual words or entire sentences, depending on how accurate, on how much data we have as well. So the word bank will have a different vector in the context of river bank than in savings bank. Okay, because the numeric representation of these words is going to be different. So we can use semantic search. So semantic search means word search, right? So we're looking for the semantics, for the understandings of these words translated into vectors and embeddings. So embeddings can represent more than just text. We can have an entire document, we can have images, audio, and so on and so forth. So if you have used, for example, GenAI audio generation, I'm sure probably you have heard there are GenAI audio generating tools that can produce music already. And I have found some really good music produced by GenAI audio models. You will find that those audio files have embeddings and have vectors, and that is the main unit that the training data will be built upon. So in a semantic search, if we just relate to the word search, we will analyze the distance between these words. So here we have a collection of numbers that is going to be a vector. And here we have another vector. So we use a 3D dimension because we can have multiple variations of the same word and so on and so forth. And it's going to give us a better accuracy rather than a 2D or one dimension only. So 3 dimension, it means we're looking at a space-like representation. And here we're calculating the distance. So I won't go into a lot of formulas, although I am tempted to. But if anyone knows how to calculate the distance between two vectors in a 3D space, please let me know in the chat. That would be amazing. Don't Google it. And you will find that the shorter the distance between these vectors, these numerical representations, then the better the similarity is going to be between these words. So if we had apple and pear, pear will probably be, let's say this dot, okay? It will be closer. Okay. So you would calculate the distance as a square root of the difference between these two numbers, of the squares of the difference between these two numbers. But I promise no formulas today. So the semantic search is going to be used in our case. We have a source data, and we will use an embedding model. So first, we will encode our data to be able to understand and to give the understanding further to the computer. And then later on, we will obtain a vector index. So the vector index is going to be used in our graph to retrieve some information. Okay, so when a user submits a question here, we have a let's see, how many steps? 7 steps process. So let's go for the diagram. We are asking a question, okay? And then we're going to not go to the LLM, we go to the retriever. So we have this agent, we have this, let's call it, let's get into the Christmas spirit. We have this elf that is going to go and find the information that we need, right? So we will need to go first and search into the embedding model if there's something existing. If not, we will create an embedding, we will pass it back to the retriever, and then the retriever is going to search in the vector index. Now, the vector index is going to give us a result. So we pass the result back to the application, and in the end, the LLM is going to give us a response. Okay, so consider this as your super secret um, assistant that is going to help you find the correct information, and if not, it's going to probably create some information, but you have to be mindful that the new information might not be accurate. Okay. So you can see a new connection here, and you will also be able to use this connection to start with the tasks of this workshop. So if you would like to follow and also work on the exercises that we have, you can also do that. If not, you can do it as well later on. You just need the Graph Academy account. So I'll keep it split screen for now because you will see here a server connect. So you are connecting to the Graph Academy server and you will be given a sandbox. So this sandbox is going to be what you will need in order to connect. Okay, so if I run this, I will see the plot of the movie Toy Story. So in this example, you should be able to also run some cipher queries. So the cipher queries are going to give you the chance or the tools to query the graph database that we're using in this example. So we're using the movie database just to keep it as engaging as possible and to give you a simple scenario for you to understand what is happening behind these queries. So the embeddings, they have been created for 1000 movie plots because of the memory restrictions, and we would like to keep it as light as possible for learning purposes. So you will find that in the Toy Story, you'll have a plot embedding. So you'll see the records have been truncated because they are too large to display. Okay. Am I going too fast? Is everyone able to connect? All good? Connection problems?
Yeah,
You might need to log out and log in again or restart your browser. Yeah, the server connect, but it should run automatically. You should get this automatically.
no.
Yeah.
Yeah, let us know if you have issues. A refresh often helps. If you are behind a company firewall, that could be that you're not able to continue here.
Yeah.
But if you are generally not blocked by any firewall or something, then it should all work by default.
Okay, so while everyone is setting up their connection, what we've done is we have created the movie plots vector index. So the vector index is what we will use to search for information. Now, there is no browser plugin. I just needed to log in, and that's it. So I found when you need to update your Chrome as well, this might be causing issues. But if you're not able to connect right now, you can follow along and watch the recording and perform the tasks after the session as well. Okay. So when we query the vector indexes, we are actually going through finding the number of nearest neighbors. That's going to be an integer. And we're trying to find, thank you. We're trying to find here how many neighbors for every single node in our movie database we can find. Okay. So I will close this just so we can go into slides mode. Let me refresh. Okay. So in this sandbox, you'll already have the data populated. And what you need to do is just run the queries. So we ran this query and we've seen that the plot for this movie is, for Toy Story, is a cowboy doll is profoundly threatened and jealous with a new spaceman figure supplants him as top toy in a boy's room. So this is the plot of the movie that we have in the database. So these embeddings, again, are going to be limited. And if you query based on the examples that we found, you should have a result. But also, we are encouraging you to find other examples as well. So the movie plots vector index, this is how it's called. We have already created it for you, and you should be able to find it as well in your code. Okay, so the index name here is going to be the name of your vector index. So in general, you should be able to have a string type index name. Then we have a query, we have a number of nearest neighbors, and we should be able to have two arguments. So I'm explaining this because later on we'll have a Python code where we would decouple a tuple Python, and we will find that we will have a node and a score that we can display and analyze for later on. Okay, we can query for similar movie plots as well. So I have similar movie plots for Toy Story. Okay, something like kids and some drama and let's say some cartoon series and so on and so forth. Okay, so the procedure db index vector query nodes is going to find and search for the movie plots vector index to find similar embeddings. So that's why we needed to store the neighbors. Okay. And then we also need to create embeddings. So the embeddings are going to be created based on the OpenAI API key that you have. Okay. We have a question from Ilias. Is the movie's dataset available in Neo4j desktop for experimenting? You should be able to import this data in your let's say desktop instance. I've also tried it with my Aura instance and I've manually imported everything. So yeah, you should be able to import this as well as going for the example data. So the index was created for the algorithm that we have just shown. Okay. The data doesn't have indexes or vectors or embeddings created. We are going for creating this, which is good because we can give different models and analyze and evaluate the results later on. Okay. So how do you generate a plot embedding? You will need to, let's say, go for this movie and go for a mysterious spaceship that lands Earth. Give the type of the key that you have, and they give you the token. And you can also save this token as a variable or as a parameter in your environment. So if I go here, let's see, I've deleted my parameters, never mind. So here you would add your parameter, and you would give it a name, a value, and then pass it on here as the $sign and the name of your token without having to copy and paste a long key. But you can do it as well. So we're trying to find a movie plot, we're trying to create a movie plot for this movie based on the OpenAI API key that we have. And then later on, we're going to dive into finding the node and the score for this plot. So in the end, we will return the title and the plot as well, and also the score, because we would like to have a look at that as well. Okay, so to run this, you won't be able to run it like that. You will have to copy and paste your key. So let's see if I can pin the key into the chat. There we are. Okay, I've pinned the key into the chat as well. You can find it on the top of the chat. So what I'm going to do, I will just quickly show you where to put your key. So please be mindful, you don't have any spaces in the key, and if it doesn't work, you might need to look into that. Okay, so in my case, I have obtained some movie plots for this movie and some other similar ones as well. Okay, so I have something similar to A Space Odyssey, and then I have found the Alien movie. I have found something about astronomers that have discovered an intelligent alien life, and then Coneheads as well, another Aliens movie, and the Extraterrestrial. So you will see the similar movies as well, based on the plot that we have. Yes, it is a little project, and it's quite interesting to get your hands on in getting started with this, because you will see actually what these algorithms do, not just a theoretical representation, right? Okay, I'm just gonna give everyone a few extra seconds, and then we will move on. So at the end, you also have a quiz that you can do. So if you follow the workshop on our Graph Academy website and you answer correctly the quiz questions, you will have a badge that you can display on your LinkedIn. So I also encourage you to do that. Okay. If we don't have any questions, It means everyone is working on their tasks and on their queries, and I do hope there are no other errors and issues. So, is it time for another poll? Are we doing any other polls, Alex?
No, we only have this one poll, and yeah, it looks like Tony says it's worked nice. So I think people are doing the exercise, working with it.
Yeah.
So I think it seems all good. But yeah, if you have any questions, anything, then we're here for you.
Yeah. Well, if it's working good, that's what I wanted to hear, and it means that
Looks
everyone
like.
can get their hands on. There are also more advanced workshops that we do. So once you get this started, you have a badge, you move on to the next advanced workshop, you can also get a badge. And in the end, you can look at what other certifications that we have and so on and so forth, and share with us your little project that
Yeah.
we can proudly endorse as well. So we have discussed about RAG, about vectors, about embeddings, and now we are doing something more specific to Neo4j, which is GraphRAG. So it means that we are powering the graph engine with a graph database. So the graph database that you have, again, as a reminder, is the movie database that you have in your sandbox. So based on the graph, we will be able to find faster and more efficiently the similarity and the relationship between different contexts. Okay, so we have quite a large number of benefits here, and you should be able to also identify different benefits as well, depending on your use case. So one of my favorite ones is the enhanced reasoning. So the explainability part and the reasoning why a certain result has been retrieved is very important when I put down a prompt and I want to obtain some results. So based on a graph database, you can see here we have the added graph here. We will be able to obtain even more accurate information. So we're storing the vector indexes in a graph as well, and in the main graph we are able to go and find some information more efficiently. So in the graph we will go and find related nodes directly to our information. And also in the vector index, we'll go and find similar nodes. So you can see that we are enhancing the power of finding the correct answer. So a user will submit a query. The query is going to go into vector and graph retriever, not just the vector retriever. It's going to go and search in all the graph databases that it has, in the vector index database that it has, and then only is going to pass on the results. So the entities and relationships are going to be added to the context of the large language model. So all this graph information that we have is not going to just be sitting in a corner, it's going to be adding to the LLM as we go along. Okay. So in this case, so we have the movie plot graph enhanced search. So in this cipher, if you already passed the APA key, you won't have to do it again. But using the nodes here, we can have more accurate information. Okay, and you can test this as well. I'm not gonna test it on my machine right now. We can just go through it. So please note, you will need to replace SK- with your OpenAI API key, just again, in case anyone is having any issues. So, given this, we can also perform a full text search. So this is a technique that we use to combine graphs as well and further improve the information that we have. So if a user is looking for a movie or actor by name, the full text search will quickly locate these entities based on the exact text matches. So this means that based on our prompt, we will go into the database, query the database based on this information and also the vector index, and we will obtain something more meaningful and avoid as much as possible the hallucinations. So the text-to-cipher a library and capability that we have is an alternative approach. So that means that we will turn the text that is given in the prompt to a cipher query. So this is going to be a direct transformation that you will have using the Neo4j Graph database. So we are asking a question, and then we go and directly search into the graph database. We don't go to a vector retriever or any sort of other retriever. We go directly into the graph database, and we're trying to find what is the exact information. So we'll have a query, a cipher query, and we are iterating over the LLM to see where is that information. And based on cipher, we are able to retrieve the result and give it back to the user. So this is a more simplified but also more powerful system that you would be able to use using graphs. I'm curious how many of you have used the text-to-cipher so far, and if you have followed any sort of Graph Academy lessons or workshops. If not, that is perfectly fine. Okay. So not too much, but that's all right. So a knowledge graph is going to be the information that we have represented in a graph format. Okay, so you will be able to use knowledge graphs to design simplified GenAI engines, but also more powerful at the same time, which is double benefits, right? So you will be able to create your own search engines based on this technology. So you will create a knowledge graph, and then later on, you will be able to maybe retrieve some information based on the data that you have trained it upon. So the knowledge graphs can break down pieces of information into chunks. So chunks are smaller text that you will use to go through through iterating over the text. Okay, so we will be able to organize the chunks that we have or the words that we have, and also represent them all in terms of in a shape of graph. So for example, when we are designing the Graph Academy courses, so this is something that we all do as technical curriculum developers, we will design the course as being split into modules, and the modules are split into lessons. We can split the lessons into sections later on, but they will become a bit too granular. So we manage everything at the level of a lesson, because that helps us in keeping the lessons small as well. Okay. So the organizing principles are quite important, because you will have, let's say, a lesson here. Let's say the name of the lesson is grounding LLMs, and the order of the lesson is 2. So this means it's going to be the second lesson that is going to come in our course. So this lesson is part of this module. So this module has more lessons. It has 2 lessons, right? So this is the second lesson. This is the first lesson, and they both are part of this module, and this module is part of a course. So we can define the opposite way relationship as well as being is part of, or you can be as creative as possible. But the idea is that in a lesson you can have also a type, So you can have multiple types of lessons. You can have conversational lessons where you can include our GenAI model into asking your learners or giving your learners the chance to ask more questions. Or you can have quizzes as well. You can have videos. You can have practical lessons. So this is how we manage the different types of lessons without losing the simplicity. And now you've learned how to be a curriculum developer as well, besides the GraphRAG. So in the GenAI applications, you also have, let's say, information that is going to be confidential. So you can keep that as confidential as possible, but you can also use it as a resource or as a source of truth to give you the explainability factor. So the explainability factor is given by the reasoning or the source of information that your AI model has. Okay. So when we create these graph models, we go through the sources, we analyze the data, we define a graph schema, and then we create the graph. So in this workshop, you don't have to necessarily do this because you have been given some ready-made data. But when you are starting from scratch, you will have to do these steps or try to automate them in a way. Okay. So let's get into more practical activities. Neo4j has a GraphRAG package for Python. It has for other programming languages as well, but today we will use Python. And if you're curious about more courses related to this, please check Graph Academy because you will have plenty of resources. Let me close this. So this package is called Neo4j-GraphRAG. You will also have it available in our provided GitHub repository. Excuse me. So in this package, we'll have retrievers, we'll have GraphRAG pipelines, and we will have knowledge graph constructions. So we provide all these tools for you to get started, and you will also be able to test them in this workshop. Okay. So in this repository, I don't know if Alex, if you have the window open, if you can copy and paste. Otherwise, I can send it on the chat. You're mute. That's fine.
I don't have it open at the moment, so if
Okay.
you can quickly send it over, that would be nice.
Yeah. So we provide this free of use. You can use this for your learning experiments and to get started on how to use Python in terms of the Neo4j and GraphRAG implementation. So you don't need to have an IDE set up already. You don't need to have Python installed already, because sometimes when you are attending a workshop, you think, oh, it would have been great if I had all the tools installed on my machine, but you don't have to because we are using code spaces. Okay, so when you click on create your code space, something like this will get spin up by GitHub. I already have my code space where I've experimented with many things. Okay, I'll need to stop some. That's fine. I can walk you through what you need to do. So you can also develop on your local machine, so nobody's stopping you from that. While your code space is launching, you can also look into cloning the repository on your machine. So from GitHub, you can just clone this on your machine or download it if you want to call it so. You will need to install the required packages using pip. So even if you are in code space, I have found you will still need to do this, but you don't need to create a sandbox. Okay. So when running this workshop, you will need to create a .env file. Now let's go back in CodeSpace. Let's see which one I have. So in your code space, you will have something like .env.example. You can rename that file to be .env, or you can create a new one with these specifications. And inside, you would need to give your Open API key and the details of your sandbox. So in this case, you'll have the IP address of the sandbox and the port 7687 with the username Neo4j and the password that is given in the workshop. Okay, so to test your connection, let me close this. Test your connection. Let's see if I can retrieve. So you'll have to run the test environment.python. So it's going to be here in the GenAI fundamentals folder. And let me just change to that. So we run first the test environment to check that our connection works. Fingers crossed. Okay, someone is telling me to zoom in. Okay, so this is a connection failed because my details have been changed. So I'll need to change here. And also the password has changed. So you'll notice that if you leave after a while, you will have your sandbox details being changed for memory purposes. Okay, thank you, Henrik. Have a good day, and let us know your feedback. Okay, so I'll quickly copy the password as well. Save the file and run it again. Okay, so when you see the OK text here, it means the connection was successful. It means I have managed to connect to the Graph Academy sandbox, which is always my favorite best news on the day. Okay, so once you have set up your connection, you will be able to go through the steps again. Take it easy, don't put extra spaces or leave blank lines because the connection would fail. Please take a lot of care when you set up this part and pay attention. So once you're done with that, we can go to the vector retriever. So the vector retriever is going to be the part where we will potentially add some new code, but you can also copy and paste the code. So you would need to connect to the Neo4j database, which is what we've already done. We would need to create an embedder, and lucky us today, we already have the code here. We will need to create a retriever as well, and you'll have the code in the workshop as well that you will be able to investigate and run as well. We will use the retriever to obtain the results and search for similar movies. and we will parse the results. So parsing the results means we will be able to print them on the console, on the terminal, so we can find them and we can have a look at them. Okay, so in our code space or on your machine as well, you should be able to have a vector retriever.py in your GitHub repository. So if you have cloned this repository, you should have these files as well. Nothing changes, it's just you run everything locally. So looking at the vector retriever, we will have some code to add. So you will have some comments such as create retriever, connect to the database, create the embedder, and so on and so forth. So you will have here the steps that you need to do to paste the code. So if you get lost, you should have a template like this. And then at every single step, you would add the block of code from the next steps. So here is where we set up the connection using our driver. Okay, so if you'd like to learn more about the Neo4j Python driver, you will have a full course about that. So we're not focusing on that today. Now, the first step is to create the embedder. Okay, so the embedder is going to actually create embeddings for our movies dataset. And the model that we're using today is this one. It's called text embedding ADA002. So please make sure you're using this one for the purpose of this workshop. Okay, but if you'd like to try more packages, this is the API documentation from our Neo4j website. So you can find multiple types of models as well and information on how to use them. So for example, if you don't want to use OpenAI embeddings, you can use Azure OpenAI embeddings. You can use Olama embeddings, Vertex AI, and so on and so forth. So you can scroll through this page and you will have quite a lot of resources that would help you to learn and experiment as much as possible. Okay, so the next step is for you to copy and paste the code for creating the retriever. Have I just gone back? Yes, I have. Okay, we're back. So again, this is the code template that you will have, the vector retriever. Please make sure you make the code changes in that file. So you will need to copy and paste every single block of code. So you have the retriever. And then once you have created the retriever and the embedder, you will have to define a search. So to test if your code works, you'll have to search for something similar to Toys Coming Alive movie. So we will need to go through 5 nodes around this movie, and we will need to parse the items, the results, sorry. So parsing the results means we will print them on the console. Now, if you get stuck and you don't know what to paste where, you also have the complete code. So if you get stuck, you can use the complete code, copy and paste it into your vector retriever, and you will be able to move forward with this workshop. So when we will test this code, we should be able to find something like this. So something similar to our movie would be Toy Story, also Pinocchio, Adventures of Pinocchio, Jumanji, and Secret Adventures of Tom Thumb. So let's see if we can do that. So to run this file, you would do vector retriever.py. Is this visible enough? So based on
Yes,
our
this is
search movie, thank you,
visible.
Alex. Sorry?
This is well visible. Thank you, Irina.
Okay, thank you. Because I have seen some messages asking to zoom in. So based on our movie, we have found some similar movies as well. So you can go and try and find the similarity for other movies. And let's see if, for example, we choose Jumanji and we go back in the code and we replace that. So instead of toys coming alive here, you would replace it with Jumanji. So let's see if we can obtain something. Actually, no, I won't clear. Okay, so similar to Jumanji, we have Jungle Book, we have Mortal Kombat, we have Dunstan Check-ins, and Jurassic Park. So these are going to be the top 4 or 5 similar movies that we have found based on the search that we have given. So here, the search is going to be the part that you will use to test. So if I change this to top 10 related similar movies, now I can clear the screen. Okay, I will obtain 10 movies that are similar to the one that I'm searching for. So you can have fun by searching for other movies or actors and so on and so forth. But in our case, we have set up the embeddings and everything for the title of the movie and the plot of the movie as well. So keep that in mind because you might need to add additional code. Okay. So once you're done, don't forget to complete the quiz here. So for example, why do you need an embedder when searching a vector index? And you would need to provide the answer. I won't give you the answer because that wouldn't be fair. And once you do that, it will add to your LinkedIn badge as well. If anyone has any issues in running the code or any questions, please let me know. Otherwise, we will move to the next step, which is the RAG pipeline. So we've done the vector retriever, and now we are moving on to working with the RAG pipeline. Okay, so I already have my connection established here. You wouldn't need to do that again, but just to confirm, you are connected. So we're going to move into the vector-rag.python file, and we would need to go on and modify this code. So this code is a template that you would need to use, and you should be able to use it for your own embeddings as well, based on the documentation that we have. So here you are importing the graph databases from the Neo4j libraries. We have the GraphRAG packages as well, and we do have the vector retriever packages as well. So you would need to go through setting up the connection again in this file, but given that this is already provided for you, you don't need to change anything. And then we need to make sure the embedder model is the same here. So that's why we are making this this highlight. So please make sure you keep the same embedding models, otherwise you might find different messages or even some errors depending on your data. So we have the vector retriever from the previous file, and then the next steps are to create the LLM, create the GraphRAG pipeline, and search for a certain piece of information just so you can test. And in the end, we close the database connection just so we don't leave anything running without any use. Okay? So why do we need the LLM? We need it to generate the responses based on the user's query and the context provided. So here in Python, all you need to do is to give the model name of the LLM. So in our case, we're going to use this model. If your license provides, if you have, let's say, a business license that would give you access to more advanced models, you can just give them here. And obviously, the more powerful the model, the more accurate the LLM is going to be. Okay, so if you want to make changes to your model, you can do it on this line. But the license that this OpenAI API key that you have in the chat is for this for using this model. So stick with the default wherever you can, and the purpose is for you to have some meaningful results and to learn how it works. Okay, so if you need to make any sort of configuration and give a temperature as well, this is where you can do. And you can have a look at our documentation on which LLM models we support. So if you want to experiment after this workshop, and I would strongly encourage you to do so, this is the documentation. So let's see, there we go. So these are the LLM models that we provide. So you can find some parameters for every single model. You can, for example, you can find message history, system instruction, and so on and so forth. Can everyone hear me?
I have no sound issues, so
Okay.
I don't. Probably on your side, Daryl. Maybe there's a little. I think there's a little mute button on the actual video screen. So if you maybe by accident clicked on that, that muted maybe the screen, the broadcast for you. But yeah, everything is okay from everybody else. So I think it's fine.
Okay. Thank you.
Thank you.
Okay, so you should also be able to create your GraphRAG retriever. So just to do that, you would need to import the GraphRAG package and then store it in a variable so you can call it later on. So this pipeline would use the retriever to find any sort of information that is going to be meaningful to the user's query and pass the query and retrieve the context to the LLM. So this is going to be very important, and it's very easy to just create everything in one single line of code. So this is the fun part where you get to test the code. And this is where you would go and use the search method to submit a query. So for example, find me movies about toys coming alive. And you would want to just find the top 5 closest similar ones, okay? And at the end, you would print the answer. So just show the answer on the terminal so you can have a look. Okay. So if you don't want to copy and paste each block, you can also find the complete code here. I would suggest go and experiment with each block of code and write it there first before taking everything from here, but it is absolutely your choice. So here you have all the code needed. So what I'll do, I'll copy this code. Let's see, do I have everything in already? Yep, I do. So this is everything that you needed to have in your Python file. And let's test it out. So I'll do Python vector underline rag. And let's see what I have. Okay, so I have the Toy Story that is similar to the prompt that we have given. So we have asked, find me movies about toys coming alive. So toys coming alive probably is going to be Toy Story. Has anyone seen Toy Story? Yes, no? If not, it's quite a good one. Okay, Alex, you have seen that story. Okay, awesome. Good, good, good. Okay, so I'm curious if we change the prompt. Let's say find me movies about cars because I want to see movies about cars. So I'll just clear my screen and run the command again. Okay, so we have 3 movies about cars now. This database has gained more favorite points from my side now because it has 3 car movies, and yeah, we can find them using the retriever, and you can just give it a prompt. You don't have to write any sort of code or create any sort of special cipher or create additional things. So just put in the prompt and you'll be able to obtain the results. Okay, so this is the whole code that we ran. And then we want to add additional information to it. So we're going to add some context. So we can return the context that was used to generate this response. So I want to understand why we have obtained some information. Why did I get 3 cars movies as base of my result? So at the end, I'll just copy this line. So after print response.answer, I would just give the context here and just rerun the file again. Okay, no attribute items. So it must be something in my setup. Let's see. Oh, there we go. I forgot to copy this part. So return context equals true. This is going to be the variable that is going to enable the context to be saved. Okay. That's what happens when you're in a rush to make it work. Okay, now we have something. So based on my prompt about give me some cars movies, um, we have here all the nodes and all the information. So this is the information that we have about cars, okay? And the plots of these movies as well. So we have some score of these movies as well. We've got some labels. Retriever result item has a title and a plot, which, if you remember in the beginning, we have established that we will obtain a set of information that contains title and plot as well. So this is why we have obtained those car movies. Okay, so the responses are also going to have some randomness. So that means that we should be able to experiment with the temperature parameter in the LLM configuration. So if you are curious, you would have here the model, and you would be able to give additional details. I'm not going to show you the code because this is going to be a challenge. So you should be able to configure the code to set up the temperature. And if you remember, we had some slides about that, so you can find them here in our GraphRAG workshop. So have a look, try to change the temperature and test it out how it works for you. And at the end, you also have a quiz. So the quiz is going to be pretty much trying to evaluate if you understood the purpose of the GraphRAG pipeline. Okay, so the additional task, the temperature task, is not mandatory, and that's why we're not giving the answer here. So the mandatory part for you is to run the code and also answer the question of this quiz. Okay, now we're going one level higher, so we will be able to have graph-enhanced vector retrievers. So if we go back to our repository, we have left two other Python files. So the vector cipher rag, this is the file that is mentioned here. So this is the file that we will need to go on next and modify. So you'll have the template of the code. So you will need to set up the connection, import everything needed, and create the embedder, define the retrieval query, and you will see now after equal, you don't have anything, and you would need to add the pieces that are missing. So you will need to use the GPT-4o model and describe a query text. So find the highest rated action movie about traveling, for example, and we want to go through the top 5 movies. So this is going to be your task, to configure the cipher retrieval query that will traverse the graph and create the vector cipher retriever itself. So if you went through the previous lesson code, you will be able to find the retrieval query and the retriever as well. So you'll need to add them to the code. So please note, for the retrieval query, you will need to use cipher. So the cipher is going to be added into 3 double quotation marks, just so it is completely understood and parsed by Python. Okay. So next, you will need to use this piece of code to create your retriever. So this is going to be pretty much what we've done in the previous slides, but we're adding the retrieval query. And in the end, you should be able to obtain some interesting results. So to view the complete code, if you don't have if you don't have the time right now to go through every single block, you can reveal the code. So I will copy and paste it into my environment as well. So this is everything that you needed to do. Have the embedder, have the retriever query that you can also find in the previous slides. We gave us an example. You'll have the vector cipher retriever, and so on and so forth. So the query text is going to be the fun part where you test this algorithm, and you can also change here on how many nodes away you would like to search. So I'll just replace it with the already given solution. I hope I don't have any typos. I do actually. Okay, so we have the highest rated action movie about traveling to other planets is Aliens, with a user rating of 3.9 and many other digits here. So this is going to be an accurate calculation of the rating, and so on and so forth. So you are being given the context as well, because you are setting it, you are printing it here, and you are setting it to true here. So these are in total 5 movies obtained as part of this test. So if you want to test more, let's say I don't want to be given so many, I'll just go to 2. Okay, I only have 2 movies being given. So this is how you can test. You can also change the text here to whatever you'd like that is going to be relevant to the movies, and try to understand how it works and how you can actually apply it to your own data set. Okay. So when we went to testing this query, we would need to understand why have we been given a certain answer. So if you're having unpredictable responses, you can change the temperature of the LLM. So here we go. Now you also have the solution for the previous challenge. So when you go through setting up your LLM, you give the model, and also you need to pass the model parameters as the temperature. So you would need to modify the temperature and analyze the results if you are happy with the accuracy or not. And we have an optional challenge. Here you would need to modify the retrieval query to include the directors of the movie in the context. So that means that you will need to modify the cipher query that you have in your code. That's part of the retriever, and you would need to make something like this. Okay. So this is an additional challenge that if you get it successful, you can also paste it on our community chat, and would be more than happy to see that. So the last part of today's workshop is the text-to-cipher retriever. So when we are using text, then we want to be as efficient as possible, because we are aware that sometimes the changes of a text can be also quite meaningful, and we would need to keep the accuracy in place. So for example, what year was the movie Babe released? We would need to have a cipher query generated. So from the text itself, the text to cipher is going to generate the query itself, and it's going to give a result. And the response is the movie Babe was released in 1995. So you can test this as well in your instances, and also you can ask more questions based on what we have in our dataset. So the retriever itself is in the text to cipher rag.py. So that's the Python file that we have left for today. So this is the 4th file that we need to modify. And we have a template, so we would need to create the LLM after we've set up the connections. We would need to build a retriever that is going to be a text to cipher. We need to give the LLM model. So here we don't set a temperature, but if you'd like to do it, so now you have the solution on how to do it. Set up the RAG pipeline and retriever as well, and we would go through testing using the text. Which movies did Hugo Weaving star in? So we will have the search here stored as a response, and we would set the context to true here because we want to understand the explainability of our results. So also we print the cipher query just to test what kind of cipher query has been generated based on our text. And at the end, we close the driver. So you can either, again, you can set the temperature or not, it's totally up to you. But in this example, you can also copy and paste this code. And you would need to use the text to cipher retriever as well. So that will need to be imported directly into your file. And I will copy and paste the complete code that is obtained after you just copy and paste every single block from above. So I'll just go into that. Okay. So first we're going to test with the given query, and then we will test with one more other question from here. Okay, so we have Dracula Untold of a rating of 6.3. We have the Stretch movie with a rating of 6.5, and the cipher query that was created based on our text is this one. So match movie in genre relationship, and then looking for the genre nodes that have a name of action. So we are returning these as a title, as a year as well, and a rating. So we have the title of the movie, the year, and the rating. And this looks quite decent, I would say, for our results. And we are also able to find the context here. So when you go for printing the context, this is how it's going to be displayed like. Now, what I'm going to do, as we said, we're just going to test with one question from here. So we have, let me delete this and I'll do this. So I'm expecting to see something like finding a count. So yeah, we do have the count procedure here, and I'm trying to find how many movies I have obtained in the sci-fi genre. So in total, in this database, we have 792 movies, and we are being given the context here. And this is the context provided. So we have recorded 792 movies based on the count function. So you also have more examples if you'd like to test. You don't need to do all of these examples. These are just for you to understand and to learn. And the challenge is for you to update the text-to-cipher retriever to contain the examples obtained above. And you will also be given the code. Okay. So this file, the text-to-cipher retriever, is going to automatically read the schema, but you can also give the schema in the code. Okay, so you can add it to the text-to-cipher retriever and analyze if you have pasted everything correctly. So this is the whole code that you should have after pasting all these blocks into your file. Okay, so these are optional for you. And the idea is for you to experiment by submitting complex queries and also try to analyze what is the difference between different LLM temperatures as well. Yeah, so just to wrap up, you can create different types of GenAI frameworks that would support use cases like RAG, or Retrieval-Augmented Generation, agentic workflows, which we have another webinar for that as well, and we also have we do have some really nice information in our blogs and in our docs as well. And you can use this in knowledge graph construction. That you can find more courses in our Graph Academy on our Graph Academy website. So for Neo4j, these are the popular GenAI frameworks that we experimented with, and we have tested the accuracy. So for example, there are some courses that we have about LangChain and so on and so forth. So you can do, based on these, on what you've learned today, you can start creating these frameworks or work with them as well. So also, this is a documentation that I refer to. And I think this is the last quiz that you need to submit. So if you didn't have time to submit all your quizzes, don't worry. The materials and the workshop is going to be available without a timer, and you can do it at your own pace. The idea is for you to learn something out of this workshop and not be rushed by the timer. So this is going to be the last quiz that you need to do in order to obtain the LinkedIn badge. And that was everything for today. I'm quite happy about the activity we've had on the chat as well. And if you have any questions or any suggestions for future workshops, please let us know.
Super cool. Thank you very much, Irina. That was great. Great pacing as well. And yeah, thank you very much, everybody, for participating, for your questions, for your show of hands that you were able to complete and were able to follow along with the code. And as Irina said, everything is available for you to try out at a later stage. Obviously, the OpenAI key will be deactivated, but so you have to either use your own or use a free model that that you are working with. But generally, everything is available, and you can also check it out at any time later. And this is perfect. Yeah, we have so many other courses available on the Graph Academy, so many interesting demo applications around GraphRAG are on our developer pages available. So if this now whetted your appetite for more, definitely go on our pages and explore some more. Or like I said in the beginning, right, Nodes AI is coming in April, and that will be the big AI event coming up. So we'll do more towards that. So definitely another round of workshops, definitely another round of interesting talks and sessions. So if that is interesting to you, register now, and you'll be informed if anything changes and added. And yeah, the recorded video will be sent to you by email, so you'll get an email from the team as a follow-up within the next few days when the video is ready for it. So expect it to be, well, today's a Thursday, so maybe early next week or maybe tomorrow, depending on how quick everything gets processed. Yeah.
Yeah. Awesome.
Okay.
So,
Cool. I think that's it. I've shared also the feedback form with you. Also, if you have a few minutes after this, it would be nice if you could fill it in and let us know what you think of the workshop. And yeah, I hope to see you soon around an event, meetup, live stream, or another workshop. Yeah, thank you, everybody. Thank you, Irina, for leading us through the workshop today and for your for your great work on the workshop itself.
thank you. Appreciate it as well. And thank you for always being here and monitoring the chat and making sure everything runs smoothly. And thank you, everyone, as well, for joining this workshop. I'm looking forward to seeing you all on our future workshop as well and posting your LinkedIn badges. So I'm very curious how many of you are
Yes.
going to do that. That would be great. I will give a like. If you tag me on your LinkedIn post, I'll give you a like on your LinkedIn badge.
Cool.
Thank you.
That's
Have
the
a good
next
day
version of
and
it.
enjoy the upcoming weekend.
Exactly. Take care, everybody. Bye bye.
Bye bye.